I'm gonna have some practice problems after I do this explanation. For uniformity purposes, let's use 1.7 as the normal adult body surface area. Is that clear? Thumbs up. Normal adult body surface area is 1.7. Okay. Now, I'm leaving it up to you if you want to remember the formula in household or in metric. But know that if it's metric, it's over 3,600. And if it's in household, it's over 3,131. And you should remember that metric is centimeters and kilograms. And household is inches and pounds. And you have to remember that all of these are inside the square root, not just the numerator. Is that clear? So let's try to solve this practice problem. I'll clear my drawings. Josh, can you still see my screen? Let's do one. Okay. Josh, who weighs 65 kilograms and is 85 centimeters tall. We're just calculating his body surface area, okay? So just calculating the body surface area. If I know both formulas, I'd right away use, what do you think? It's in centimeters and kilograms already. I'd right away use, which one? The metric. And the way to do that would be 85 times 65, press equals, divided by 3,600, and get the square root of that. Don't know your calculators. Each calculator is different. Some calculators you will have to press square root first, and then plug in the numbers. Some calculators you need to plug in the numbers first, and then press square root. Some calculators you need to plug in the numbers and then press second function, then square root. What's the answer to this one? Josh, who weighs 65 kilograms and is 85 centimeters tall, body surface area would be what in meters squared? You can put it in the chat box or you can put it in the whiteboard. Answers can be in the chat box or in the whiteboard. I'll clear your whiteboard. Again, you must have a calculator with a square root functionality. So that will be 65 times 85 divided by 3,600 and get the square root of that. Put your answers in the chat room, in the chat box. Make sure you know how to use your calculator. I can't teach you how to use your calculator. You must have a user manual. You can easily look them up online now. Okay. Correct answer is 1.24 meters squared. 1.24 meters squared. One more, and then I'll jump to the application of this particular topic. One more. Maggie, next one. Elizabeth, Christine, you still with us?
Yes.
Okay. Maggie, all of these worksheets we're going over is in your Friday folder. I've already uploaded them in your Friday folder, so don't email me and say, Miss Elle, where is that worksheet that we did live? Everything is in your Friday folder now, okay? And the ones that I'm going to use on Monday. Okay. Maggie, let's do this. 40 kilograms is her weight. Her height is 65 centimeters tall. Answers in the chat box. We're only calculating for body surface area. So you may use either of this formula, square root of height in centimeters times weight in kilograms over 3,600, or height in inches times weight in pounds over 3,131. That's your household. Get the square root of that. Okay. Correct. The correct answer is 0.85 meters squared. I leave it at that. I'll share with you another worksheet, which is application of body surface area. Okay. Because I'd like you to start solving this problem. This is again uploaded in your Friday folder, so don't worry about it. And we'll do the worksheet application for body surface area right now. Application to dosage calculation. Can you see my screen? Can everybody see my screen? Yeah, okay. This is an application of body surface area problem, dosage calculation. Compute the answers. If you want a reference, it's in your Friday folder, okay? Friday folder worksheets to do. Compute the answers to the following questions, which are based on the child's body surface area, using the following information about the child and their order. Okay, I'm gonna go use my annotate again and draw. And right here, I will try to do this. Okay, so Sarah, whose body surface area is This should be 0.45, okay? 0.45. Do not forget the leading zero. Meter squared is to receive Keflex 2 milligrams per meter squared TID. I will underline this or put it in a square so that I don't forget that it's TID, okay? Oops, let me go back to it. I'll draw right here. Okay, so I will underline the TID so I don't lose it, okay? The supply dosage available is 5 milligrams per ml. Are you still with me? Okay. So 5 milligrams per ml right over here. How many milligrams of Keflex should she receive per administration is the first question. How many milliliters of Keflex should be administered per dose is the next question. This is the second problem, okay? So we'll stick to this one first. Do not focus on the next one yet. Not yet, okay? So how many milligrams of Keflex should she receive per administration? Let's see what we have. So what do we have? 2 milligrams. Can you see that? What do we have? 0.2 milligrams for every meter square. I'll put 1 here. There's an invisible 1 so I don't get lost, right? Equals X milligrams over, I have a body surface area given right over here, right? 0.45 meters square. Now, 0.2 times 0.45 divided by 1. I now know that I need to give 0.9 milligrams of Keflex per administration. Can you follow?
How did you get the 0.2 milligrams? Because it says in the problem 2 milligrams.
Right here. I'm sorry, you're right. It's 2 milligrams. I'm sorry. Elizabeth, you're correct. This is not 0.2. Let me do that again. Clear it. Clear all drawings. Okay, let me try it again. Okay, so let's go back. This is your 2. You're correct, Elizabeth. Good catch. 2 milligrams for every meter square. I'll put this invisible 1 over here so I know that it's not an X, okay? This should be 0.45. It's hard to see the 0 because there's no 0 in there. This is an old packet, so it's not yet following the do not forget the leading 0. 0.45, nope. This has to be erased, this one, because it has to be where? The meter square has to be in the denominator, correct? Are you still with me? Yeah? So what I'm trying to look for is this, X milligram over 0.45 meters squared if I'm trying to use ratio and proportion. Then it's 2 times 0.45, correct, Elizabeth, divided by 1 should give you 0.9 milligrams.